only way to learn mathematics is to do mathematics. Welcome to another tutorial video in my channel. So today we are going to solve geometric problems involving quadratic function. So in this tutorial video, we will be just focusing on geometric problems that involves quadratic function. So on the following slides, I will be presenting two common word problems when it comes to lesson like this. So again, the only way to learn mathematics is to do mathematics. Just have that positive mindset always, so that yourself will not suffer. Okay, before we are going to discuss the problems, the examples, let me just give you some steps in problem solving. Number 1, read the problem several times until you understand it. Most of the students will always fail on this first step, because the tendency is after reading the problem and then you don't tend to analyze. So for the first step, it says you are going to read the problem several times until you understand it, meaning it is not just about reading, you analyze, because that is the most essential. Second, determine what is being asked in the problem. This is also very important because this is our goal, to know what is being asked in the problem. Number 3, you are going to devise a plan. So in your mind, you create a plan what you are going to do, and then for the fourth step, you carry out the plan. And lastly, you look back. Look back meaning it's an elegant way of saying you do the checking. But let us have our first problem. Find the maximum rectangular area that can be enclosed by a fence that is 60 meters long. So we are going to read the problem several times until we understand. Find the maximum rectangular area that can be enclosed by a fence that is 60 meters long. So when you are reading, you take note of the important terms, especially what is being asked in the problem. So for this, we are asked about the maximum rectangular area. Maximum rectangular area. So it is speaking about area. Another hint is 60 meters long. Find the maximum rectangular area that can be enclosed by a fence that is 60 meters long. So upon reading the problem, you try to visualize what is the problem all about. So what I visualize is this. There is a rectangular area and then you are going to enclose it by a fence. So the problem is you don't know the dimension, you are just given by how long is the available fence, which is 60 meters long. So with that, when we are talking about fence, we are going to put a fence around the rectangular area. So if you are familiar with the word perimeter, talking about the distance around a particular shape, that is perimeter. And for a rectangle, it is given to be by this formula. Perimeter equals 2 times the sum of the length and the width, meaning if this is the length and this is the width, we have two lengths. We also have 2 widths. That's why for the perimeter, that is 2 times the sum of the length and the width. Or if we are going to distribute, multiply the length by 2 and the width by 2. So that's the perimeter. The problem is we don't know how long is the length and how wide is the width. But what we know is the perimeter, because the amount of fencing material that is supposed to be the perimeter. So 60 equals 2L plus W. So if you are given with problems like this, the first step that you're going to do is you need to have a measure for the length and the width, but it will not be given. That's why we need to represent it by using all the available given. So in this case, what is given is perimeter, and since we are going to solve for L or for W, and since we have 2 on this side, we need to divide both sides by 2, so that will become 30, because 60 divided by 2 is 30, and on this side the 2 is eliminated, so we only have L plus W. And then since we want to solve this problem, we just need to express W in terms of L, because we cannot solve this problem if we are dealing with 2 variables, L and W. So if this is L, then W can be expressed as 30 minus L. We just transpose L to the other side because we want to have a value for W, value for this in terms of L. So if I'm going to put that on the figure, if this is our length, this one is the length, this is also understood that this side is also the length, and then from our solution, the width can be represented by 30 minus L. The other width can be also represented by 30 minus L. So now if you are going to check if it's correct, if the perimeter is 60, if you are going to add all of these sides, the length of all the sides, that will sum up to 60. Now after getting representations for the length of each sides, we can now proceed with what is asked. Find the maximum rectangular area. So it is talking about area. So meaning we can also use the formula for area, which is area is equal to length times width. And since we already have values or representations for length and width, we can substitute. So we have area equals length. The length is L, represented by L. The width is represented by 30 minus L. And then applying distributive property, L times 30 and L times negative L, you will have 30L minus L squared. And then transforming this one into its standard form, you will have A is equal to negative L squared plus 30L. So at this point, let me emphasize this one. This is a quadratic function, and then this A is just dependent with the value of L. If you can recall, when we are talking about function, it is related to the word dependence. So in this case, the value of the area will just be dependent on the value of L. So meaning, this is a quadratic function. And since we are asked about the maximum rectangular area, if you can recall the graph of a quadratic function, the value of A is negative 1, meaning if you are going to graph this function, the parabola is opening downward, and then at this point At this point, this is the vertex. Vertex is the highest or the lowest point. So in this case, since the parabola is opening downward, the vertex is the maximum point. So at your maximum point, it is represented by HK. The vertex is being represented by HK. For this H and K, K is the dependent variable. H is the independent because H is for X, which is the independent. K is for Y, which is the dependent. So for this case, because we are asked about the maximum rectangular area, and then as I said earlier, the area is just dependent on the value of L, then meaning for the for the solution to become faster, we can just solve for the value of K because we are looking for area, or you can solve for the value of H, but you still need to multiply to find the area. So in my own preference, I can solve the maximum rectangular area using the formula in finding the value of K. So let me first give the values of A, B, and C. A is -1, B equals 30, C is equal to 0. And then we are going to use the formula in finding the value of K, which is given to be 4AC minus B squared all over 4A. And then we substitute. 4 times A is -1. C is equal to C is equal to 0. Minus, formula is minus, so that is minus. And then for your value of B, make sure to include that one in parentheses, excluding minus because it's not included in the squaring, because that will change the value if you are going to include the minus inside the parentheses. And then on the denominator, you have 4 times A is -1. And then 4 times -1 times 0, because you have 0, automatic, that is equal to 0. Minus 30 squared, that is just 3 times 3. And then you add 2 zeros, so you have 900. And then in the denominator, you have 4 times -1, which is -4. Now 0 minus 900 is just equal to -900. Divided by -4, that is equal to 225. So again, as I said earlier, the K, it signifies A, because A is the dependent variable depending on the value of L. So meaning, if you will be asked to give the maximum rectangular area, just use the formula in finding K. So you have K is equal to 225, or this is the maximum rectangular area. Therefore, the maximum rectangular area that can be enclosed is 225 meter square. Let us have the shortcut. So for the shortcut, it will always work. The only problem is your teachers might ask you to give the formula or the equation of the quadratic function, so you cannot do this one. But in case, for example, during the summative test, and then the teacher will not require solution, then you can do this, the shortcut. You might be wondering, when we have maximum rectangular area and then my figure is a square, it is because you are going to, if you are given with this problem, the shortcut is you are just going to divide the perimeter by 4. So 60 divided by 4, that is equal to 15. So what will happen? All the sides are equal to 15. That's why I'm drawing a square. And for the information of everyone, a square is a rectangle. So you will learn that during the third quarter. A square is a rectangle, and for problems like this, it is always the expected answer that for a rectangular area to be maximized, it should be a square. So for the shortcut, just divide it by 4. So if you will be asked about the dimension, then you will give 15 by 15. But if you will be asked about the maximum rectangular area, then you answer 225. So I hope that it helps you. Let's have the second problem. A rectangular garden is to be fenced off along a riverbank. If no fence is needed along the river, find the dimensions of the largest garden that can be fenced by 36 meters of wires. So for this second problem, do not be tempted to use the shortcut because it's a different problem. So if you are going to look at what is asked, again, it's dimensions and then the largest garden. Meaning, problems about quadratic function, it will always contain the largest or the maximum because it's all about quadratic function. And then another important given, we have the perimeter, which is 36 meters of wires. Not the perimeter, but just the length of the fencing material, because it's not perimeter because the other side should not be fenced off, the one that is along the river. So if we are going to have a figure, this is our rectangular garden, and then on this side, this is where the river is located. So based on the problem, no fence is needed on this side. Okay, so let us start. Again, in problems like this, these geometric problems, we need to have a representation for the length and the width. So with this, we can start with let x be equal to the width. We cannot use the same method in problem number 1 because in problem number 1, the 60 meters that is being given is the perimeter. So we can relate perimeter with the length and the width, but this time 36 is not the perimeter. It is just the length of the fencing material for these sides, the 3 sides. So we cannot use the formula for perimeter. So in that case, we can use the basic. If it's a known, then we can use any variable to represent it. So let x be the width of the field. So if I'm going to put it on the diagram, this will be the width. The width is being represented by x. And then for the length, we can let y be the length of the field. Again, I already warned you earlier that there should be only one variable. So meaning, we need to represent y in terms of x. And how are we going to do that is to use the given, the 36 meters. So 2x plus y equals 36. So why do we have this? Because we have 2x plus the y, and that will sum up to 36. 2x and the y, that is equal to 36 because that is the length of the fencing material. Now solving for y in terms of x. So what we're going to do is to transpose 2x to the other side, and we will have y equals 36 minus 2x. This time, y is already in terms of x. So instead of y, we can change that by 36 minus 2x. So this time, we already have a representation for the width and the length. So we can proceed with what is asked in the problem. Find the dimension of the largest garden. So for it to be the largest garden, it should have the maximum area. So it is just very similar to the previous problem. we need to use the formula for area, because for it to be the largest garden, it should have the maximum area. Area equals length times width. What you need to do is substitute. Area equals the length is equal to 36 minus 2x. The width is equal to x. And then history. You apply distributive property. So x times 36 is 36x. X times negative 2x, that is equal to negative 2x squared. And then for it to become beautiful, change it to standard form. So a is equal to negative 2x squared plus 36x. Again, I will emphasize this one. In this case, the area is just dependent on the value of x. And since this is a quadratic function, again, a is negative, so meaning the parabola is still opening downward, and then the vertex is a maximum point because it's opening downward. But since the problem is asking for the dimensions, instead of using the formula for k, we can use the formula for h, because it is just asking for the value of x, or the h is related to x. So we have solved for x using negative b over 2a. Again, this is very important so that your solution will be shorter. If it's asking for dimension, you use this formula. But if it's asking for the maximum area, you use the formula for k. So using the formula negative b over 2a, we can have negative b is equal to positive 36. That's why we have negative times 36, because that's the formula. Then for a is equal to negative 2. That's why you can have 2 times negative 2, which is equal to 36 over negative 4, and that is equal to positive 9. So we have x is equal to positive 9. Again, if it's asking for dimensions, meaning the length and the width, but recall that the x is just representing the width, so we need to find the value of the length, or the value of y, which is representing the length. And then how are we going to do that? Just recall that earlier we have y in terms of x. Y equals 36 minus 2x. So we are just going to substitute 36 minus 2 times x is equal to 9. So that's 2 times 9. 2 times 9 is equal to 18. So 36 minus 18, that is equal to 18, meaning the width is 9, the length is 18. So if you are going to check our answer, because that's the last step, to look back, kasi ang hindi marunong lumingon sa pinanggalingan hindi makakarating sa paroroonan. So we are going to look back, check your answer. If x is 9, this is also 9, and y is equal to 18, this one, 9 plus 9 is 18, plus 18 is equal to 36. Very good. So we are able to meet the problem. So therefore, we can have our conclusion. The dimensions of the largest garden are 9 meters by 18 meters. So I hope it helped you. So see you again in my next video. Thank you for listening.